Okay, anybody wants to tell us what they done during this time, like looking at the notebook, problems you had, or the things you have discovered? I see that somebody had an issue running locally, and thanks to everyone who helped him. That's really good. I really appreciate the effort you're making to help each other. It's making this course much, much better. All right, so somebody wants to tell us what they done or any issues you have had with the notebook itself?
Hello, Veronica. Can you hear me?
I hear you well.
Okay. I just have a ask about the save the trained model, because I think that the main problem is that we have to keep it in the same file than we upload the data, and it is a read-only file system. So I don't know if someone has solved it.
So you say, apart from the notebook, I also gave you access to, in my Google Drive, a folder that contains a file with the pre-trained model. And you say you were not able to download it? Or what was
No,
it?
I downloaded and I did, well, I ran all the whole script, but
Yes.
the last line, to export the data, okay, the file is resnet 50 dot blah blah blah.
Yes.
So when I try to save it, the problem is that it's a read-only file system, and I try to change the path and change the open file, but it doesn't work. I don't know if I'm doing something bad or it's just the only way to save it.
So when you are you running in your local computer or in Google Colab?
No, it's with the same copy of CNN transfer.ipnv.
You're running in Google Colab, is
In
that
Google
right?
Colab, yeah, with the same Python and all this. I don't know
So
if
you are also not running Wine, but you also took a copy on your own Google Drive, no?
Yeah, but I try to change the path with my own G Drive folder, but I don't know if I'm doing something bad. Well, the whole Python running is good, so I have no problem, but I can't save it. Well, it's not a big deal because I could run it twice, but
I got the same problem, and it says learner is not defined.
Can you share?
And I think that's the problem, because even if I change the...
I think I might know
what for that, you just have to change learner to learn.export.
Yeah. I already changed it because, well, it's just a bad type, but that's not the deal. But I don't know if the problem is because it's typed as OS error. It's with the OS package. I don't know if we could change it in another manner.
You say it's an error with your OS?
Yeah, OS error. Because it's
just make sure also that you run the first that says import OS. Make sure also that you mount your Google Drive, because when it says it, it has to save it to your Google Drive. And the path is not terribly important. It's just the Google Drive needs to be mounted so it knows where to save it. The way it's written now, and yes, there is a typo. The woman that was speaking before, yes, instead of learning, it should be learn. It's just a
yeah, now it works, but for me it saves and everything.
Yeah, so I think in your case...
Thank you. I didn't notice that.
No, it's a typo. Sorry about that. I think in your case, Aaron, there must be an issue. Either you didn't run the first cell or you didn't mount the G drive. Otherwise, it should work.
Okay. I will try to figure this out. Thank you so much.
And you can email me if you don't manage, or put it in a Slack because it will be faster. Somebody will help you faster.
Okay, okay, thank you so much.
Okay, so has anybody tried? Sorry, I see you run the notebook. Have you tried? I don't know, maybe trying other transferring from other models for image classification from the MINT? Any of you have tried a different set of models just to see the accuracy? Like I gave you examples of straight ahead. Where were those? Yeah, ResNet 18 and SqueezeNet. And also I put the simplest thing, which is learn fit one. Means you just do one cycle of running, and there are many other parameters you can add there in terms of what kind of learning rate you want, how many epochs you want to run. So this 92% or 88% accuracy, we mean by just running once in one epoch. And you could actually achieve much higher accuracy with those models by changing a bit, playing with the parameters, which is what I was asking you to do. But you can also, instead of SqueezeNet or ResNet, there are other options. So you could also try to see which pre-trained model might be best for this particular task. I don't know if any of you have had time. I know that the time is very limited, but if anybody has tried anything on that area. All right.
I have a question. If I want to try, as you say, another model, for example, VGG 16, in the there is a line where it says learn.load and in parentheses ResNet 34 LSC. What I have to put instead of this?
So you see in the notebook, in your app, I tell you that the Fast AI library includes several pre-trained models from Torch Vision, and I put the names of all these models. So instead of ResNet 18 or whatever it is, you have to put the name of any of those. So in the case of VGG, it will be VGG 16 subscore BN or 19 underscore BN.
But I mean two lines below. It's not in defining the model. It's loading. The line is learn.load.
So
Just above the summary.
let me just show my application, because otherwise we are talking in the, let me see. Here, this is the notebook. Here I just label, I give to you the names. Here
Yes.
we take the data, which is the MINST we have defined. I say the model is going to be ResNet 18. And I say run it once with the metric being accuracy. And instead of ResNet 18, you want something else, then you put any of those other names.
Yes, I mean more.
Below, you mean?
Yes, below.
Sorry.
Just above,
Yeah.
just above of summary. Learn.load.
About the summary. Sorry, I don't see.
Above of learn.summary.
Yes, exactly. Yes. So the model, you can take the pre-trained model as it is from the default of Torch Vision, or you can take another model of ResNet 34, but now training in a slightly different way. And that's why I share with you this folder, because it contains these pre-trained models are saved in formats that are, for example, PKL or PTH. All what they do, these files, is they contain what is the architecture of your neural network, what kind of input they receive, what kind of output they output, and what are the values or the weights as the information goes from the beginning of the neural network to the end of the neural network. So they are really simple files, and you can use the default one, which is what this command will do, or you can use the one I provided, which is slightly better when it comes to this task. And this is in the folder that I gave you. So you could either say, okay, my model is going to be this one, and train it or use it as it is, so with the weights as they are. Or alternatively, for your model, you want to still use a ResNet34 model, but load the weights that appear in here. And that's what this command is doing. So the architecture is a ResNet34, and the only thing that is changing is a little bit the tuning of the weights. It's just in our study for the LHC Olympics, we found that this was a good tuning. More
Okay,
questions?
thank you.
Welcome. And then more questions?
Well, Veronica, I tried to use another architecture, the VGGNet, but the problem is that I get an error because the images in the MNIST are too small.
Yeah,
So
that's a problem, yeah.
Yeah, now I'm trying other architectures.
Very good. So that's it. Yeah. So you can use pre-trained models, but what you're going to change, as I was saying in the slides, is in the lecture you need to change make sure you match the input shape, and you need to change the output as well, right? So to fit with the one you want to use. So in your case, indeed, that's a very good thing. So you started playing around and you realized GG is such a deep network that it has been training on very high precision images, and our MNIST data set doesn't have that level of precision. So what you could do is to enlarge it artificially, or simply decide that VGG is probably an overkill for MNIST. Essentially, you use a brain model that whose input is a very high resolution image, and you try to use it for a low resolution image. You are essentially doing an overkill, and probably what is going to happen is that precision won't be that high. So these are not 100% sure, but it's worth trying. So you try to reshape the MNIST data set to the same shape and see what is the performance. You might see that drop in performance just because a lot of the MNIST, once you enlarge it, is useless, or it's just empty spaces. So it just makes the whole performance for VGG with all the weights frozen not to do so well, because it's more adequate for a high resolution image. That's good. That was precisely what I wanted you to do, is to play with different ones. For example, I put there ResNet 18 and not ResNet 34, 50, 101, 152, because those are huge data sets. And the idea is that they are, you are going to end up with simply overfitting. And the same for SqueezeNet. It's not doing great because SqueezeNet is mostly training on activities and objects, for example, a car or somebody running or stuff like this. And this is very far from our data set of just images of handwritten symbols. Any more questions? Not? Right?
Hello, Veronica. One question.
Yes.
It took a while to download, so I didn't have much time to play around, but I was checking the particle physics example. So if I understand correctly, we're using here a network that's already trained, but we're not training it further, right?
So no, only the last layers. So the default, that's that's great. Thank you for the question. So when you call the model and you say CNN learner, and you say that's the data, the model I'm going to use, and so on. There is a default of how many layers are going to be taken off of the CNN learner. And the default will be just the last layers that are just fully connected. So you also have options to actually increase more what the pre-train is going to be. Sorry, or the training that you are going to do.
But where in the current version of the notebook is the network the neural network learning?
Oh, that's good. A very good question. Yes. So for the particle physics data, I didn't retrain. I just gave you the model, but to do it, you have this learn.fit that you could do. And then you can retrain it again.
Okay.
Yes.
Okay.
For that, just as I say, it's just a template of learning some commands you can use. In particular, if you already trained, you can just upload it. So you put your model in evaluation mode, and then you can give predictions based on it.
So before putting it in evaluation mode, we could do learn.fit.
Exactly, and you also exactly you can do the fit. You also have options to how many layers you are going to unfreeze and all that stuff. I'm sorry, I know that typically you have 50 minutes or no more than 1 hour to check the notebook before you have actual questions. Yeah, and in this notebook, it was just for you to learn some of the syntax with the idea that you will go on and then check other things, in particular options for the learner and the feed and so on. Thanks for asking, yes.
Yeah, so one more question in this data augmentation. So this one is, so it's been done, but I don't quite understand the options here.
I mean, in the case of...
in the particle physics example. So
okay.
basically seems that you create an object TFMS that then you pass
on the images, yeah.
Right. So
So the idea is that the data set I gave you for space mostly is very, very small. You have a very little amount of signal and background, and in principle that will make your procedure very unstable and not robust. But we can use data augmentation, so we can apply transformations to the images. This TFMS is taking in a random fashion your images and resizing them, cropping them. So the edges, for example, rotating them, although in this case I set it to 0, but you can rotate them as much as you want. You can flip them, warp them, meaning you stretch them and stuff like this. There are many, many options here on the transformations on images. And with that, what you do is to enlarge your data set with the images you already have, but where you have manipulated them, like we did at the beginning with MNIST.
Yes. So if in the following cell where you do data equals image data bunch dot folder,
yes,
if you leave blank the DS DM TFMS thing, then it won't do any data augmentation. So you would just read the images and take the ones that are present. Okay.
Exactly. And you will see that's a good thing, by the way. You can do that. Remove the transformations.
Yeah.
And you should see a drop in the accuracy. No, sorry, if you fit again the model and you train it with transformations, you will get good accuracy and good generalization. But if you don't, you will see how there should be a drop in generalizing, in the accuracy in the validation set.
Okay.
When you have a lot of data, like it happens in the case of the MNIST, this data augmentation doesn't give you much. As we did in this other example of the CNN, we already have 98 or 97%, and the augmentation gave us another extra 1% or so. But when you are dealing with small data sets where you think that those transformations will keep the physics the same, that's important. You should not transform in ways you don't think they make sense. Then you are going to increase the accuracy. So you will see a higher reward of doing the augmentation.
Okay, thank you.
Vale. Any more questions? And again, don't feel bad. I know that many of you barely had any time to even just start looking at line by line to the code. Some of you will go that way and try to understand every line, and this is really good as well. Or some of you are able to run and start looking more broadly. Everyone works in their own way. So I know that at this time, after 1 hour, I don't feel bad about you. No, sorry, I'm not upset at the fact that you don't ask many questions. That's just normal. I expect that if you have more questions, you do it through Slack or later on in the course before you send your report. Okay. All right. So I guess for lunch now. See you.
See you.